Welcome to episode 3 of AU Manufacturing Conversations with Brent Belinsky. Our guest today is Jon Bulman, Director of Manufacturing at the greatest Australian manufacturer you've never heard of, Finisar. We featured a story this week on our recent visit to Finisar's Rosebery factory, only a few k's south of Sydney's CBD. As promised, here is the extended interview that informed a great deal of that story. If we only had 10 seconds or so to say what's outstanding about Finisar, we'd probably say this: incredible locally developed tech enabling flexible communications networks, over 2 billion in exports, and, oh yeah, about half the world's internet traffic goes through their devices. Jon talks us through his career in high-tech electronics after moving here in 1994 from London, assembling Finisar's Wavelength Selective Switches and the complex supply chain that feeds into this, the team of 250 at Rosebery, how skills shortage and supply chain issues have affected the company in recent times, and what he sees as a resurgence in high-tech manufacturing in Australia of late. We hope you enjoyed the episode as much as we enjoyed the visit to this important enterprise, which, though US-owned, has been left alone to operate more or less in the same way over the last 2 decades. Jon Bulman, thank you very much for joining us here on AU Manufacturing Conversations. Good to be in your factory. Good afternoon.
Good afternoon. Welcome.
Thank you. Tell us about yourself, Jon. How did you get here and what do you make at Finisar?
Okay, so I'll start with how did I get here. So I graduated from university in 1986 and started work at a factory in London owned by Philips. And that factory up to that point was a traditional place where they used old machines to churn out electrical components for electrical connectors. And my manager, who was hired at the same time as myself, together we were tasked with turning this factory over to produce connectors for the fibre optic industry. And at that time, optical communications were new, and we quickly saw opportunities for many other components to be used in the fibre optic industry. And so within a few years, we'd replaced all the machines that were originally there for the latest high-precision CNCs from Switzerland and Japan. And we'd set up clean rooms, and we'd expanded the facility and hired more staff. And then in 94, my wife, who worked in IT, was asked to take on a 12-month project in Sydney, and we thought this would be good fun. So we came over here, and while I was looking for work in Sydney, I met Dr. Simon Poole, and at the time, he was the director of the Optical Fibre Technology Centre at the University of Sydney. Simon was keen to commercialise the technology from the research centre, and I was keen to get any work and try anything. So together with 2 other students from the university, we started a company called Index. That company grew quickly on the success of producing fibre optic components that were used by Fujitsu and repeaters in their undersea cables. And so we were soon purchased by a US company, Uniphase, when we were still only 6 people. And I ran the manufacturing and oversaw our growth, eventually filling our facility at North Ryde. And along that way, JDS merged with Uniphase to become JDS Uniphase. And our second building in North Ryde was opened by John Howard. And then in 2003, along came the tech crash that followed the dot-com bubble. And that downturn was compounded for us as we discovered that many of the projects to lay undersea optical cables were financed by companies located in the World's Trade Center in New York. So our team locally, we believed that we could ride out the storm, but the JDSU corporate told us to close the building because they were cutting staff and operations all around the world, and so we were just wrapped up in that.
Right.
So many of our staff, however, went on to have good careers in the local biomedical industry, but in the process of shutting down JDS, I passed the facility lease on to Silverbrook Research, who wanted the clean rooms. They then hired me, so surprisingly I found myself back at the same desk, but working to ramp up a different technology. And while I was at Silverbrook, Simon Poole joined with Dr. Steve Friskin in establishing another photonics startup in Ghana. And shortly after we joining Ghana, which I did basically in 2006 when they developed a novel technology for wavelength switches. They hired me to set up their production and operations, and then shortly after I joined them, Ghana was acquired by a US corporation called Optium, which in turn was then acquired by another company, Finisar. And then Finisar was acquired by 26 in 2020. However, that acquisition required approvals in the countries in which the businesses operate. The regulatory body in China required that the WSS business that we were running remain separate from 26, and so we kept the Finisar name and continued to operate independently.
Tell me a bit about the invention that got the company started, WSSs. What do they do? What are they for the uninitiated? Excuse me. Something
Sure.
to fill in those gaps, please.
Yeah. So basically, to explain a wavelength selective switch, which is a bit of a mouthful, but so optical networks transport data using light passing along optical fibers. And a single fiber can carry many channels of data, each channel at a different wavelength of light. At a site in a network, you may want to add or drop channels to follow different paths to continue along the main network or to branch out. You can imagine a switch as the intersection of two freeways where traffic can either enter or exit in any direction. The WSS selects wavelengths of light or channels on an incoming fiber and then directs them to any of the outputs. And in Ghana, invented the use of liquid crystalline silicon device to perform the switching function of a WSS. So I'll just explain what a liquid crystalline silicon device is. An LCOS is a miniaturized reflective display consisting of a liquid crystal layer on top of a silicon backplane. It was initially developed for projectors. An LCOS display has many pixels that create a very high resolution image. When used in a WSS, a prism spreads the wavelengths of the incoming light to fall across the many pixels of the LCOS. Through patterns in the image on the LCOS, the reflected light is steered into output fibers. And the range of wavelengths in the incoming light can be switched to any of the output fibers by altering that pattern in the image. And if you really want to understand it, Wikipedia's got a much better explanation.
I think I'll head there. As I mentioned, we're in your Rosebery factory. The tour was fascinating. I've never seen such a place with so many machines that build machines and programs that program programs. It was wild stuff. Tell me about what goes on here, or more importantly, tell the audience, please, about what goes on here.
Great. So from this site, we run the Finisar WSS business. Basically, we perform the R&D, the marketing, and the manufacturing. Sub-assemblies that are produced in our facilities in Asia are brought together here in our main clean room in Rosebery, and we produce the finished product. We call that the WSS module. The assembly process is straightforward. But once we've combined the optics with the circuit board, we can calibrate the module, which is the key step in our manufacturing process. Optical components like mirrors, lenses, and prisms are all pieces of glass which are aligned together using sub-micron positioning accuracies. But still, each part has its own tolerances or imperfections, meaning that we cannot assemble them to the scale of waves of light to achieve the performance wanted in the final product. However, the calibration process that we perform here in Sydney allows us to measure the optical characteristic of the individual module and then determine the algorithm required to create images on the LCOS that will steer the light to correct for small errors in the optics. In essence, the software in each module is individually programmed using an automated AI system to digitally compensate for variations in the physical optics of the components. And then after calibration, we perform tests at high and low temperature to ensure that the module will operate in all conditions. Every customer of ours has their own requirements, so every module is made to order. A customer may order one or many hundreds, so we've got a highly flexible manufacturing system that aims for quick delivery, whatever the request. From here in Rosebery, the finished modules are boxed and sent by air to customers around the world.
Australian part of Finisar and your origins, as you mentioned earlier, sort of legendary but sort of not well known to the man on the street, I guess. Saw an article from 2018 that began with a fairly captivating lead. It was a figure that said something like half of the world's internet traffic goes through devices made at this factory. Is that still pretty much accurate?
Yes, that remains broadly the case. We've produced wavelength selective switches here in volumes for over 10 years, and they've been incorporated in systems built by major telecoms network equipment companies who deploy those systems around the globe. So optical communication networks carry mobile phone, video, and internet data. In giving our share of the market, it's still fair to estimate that about half of the world's internet traffic goes through our devices. But what surprises many is that our devices made in Sydney are not only used around the world, but they perform such a fundamental role in those networks. It's the switching technology that enables reconfigurable networks architecture to exist. And over time, we've faced growing competition for our older products, and that's pushed us along a continual path of new product development for higher data capacity with increased numbers of channels and wider wavelengths, and switching to a greater number of output fibers.
What are the things about this operation today, as we see it, what links it back to the company that started as Engana?
The operation we have here today is the outcome of steady evolution from Engana's startup. Many of the key members of staff have remained as since Engana, and the approach to manufacturing remains essentially the same. However, the continual development of new products goes hand in hand with the development of manufacturing technology and machines. So the nature of the products requires sub-micron levels of precision and assembly of optical elements simultaneously in multiple axes. And so from the outset, this led us to develop our own automated machines using high levels of software to integrate measurements from optical instruments, providing feedback to motion control systems. And as our experience grows, we've extended our use of vision systems, AI, laser sensing, and robotics. And every machine is connected internally to a web-based manufacturing execution system for real-time control and data collection. As we've expanded our manufacturing operations to China, Korea, and the US, we've retained the same model. The equipment deployed at these sites continues to be developed by our teams here in Sydney, and with the data from these sites all feeding to the MES, enabling real-time view of production across all of our locations.
What's your supply chain look like here, and how's it been impacted by all the pretty well-known difficulties all around the world?
This is a key thing for us. Our site supply chain is very complicated. The key optical assemblies are made at separate locations in China, Korea, and the US. And each of these locations requires themselves specialist in feed materials that we source from across Europe and the US and Asia. And essentially, COVID continues to have unforeseen impacts on these supply chains. It can affect the suppliers of the components, the facilities where we assemble, or even the transport between them. And right now, our colleagues in China are facing lockdown restrictions within their facility. However, so far, we've largely been able to mitigate these effects on our end production and delivery to customers. But the major challenge we face is the global shortage of semiconductors. In the past, we could order circuit boards from our contract manufacturers in Asia, and they would source all the components and provide us with the assembled circuit board. However, as the global chip shortage took hold, they started seeing the lead time for their ICs increasing to over a year or more, and the normal supply chains began to fail. So to address this, we took on the role of sourcing and holding ICs ourselves here in Rosebery. So we now purchase and hold a buffer inventory of all the critical components, and we can be made more flexible in seeking these parts from brokers, and we can test the parts. However, we still need to divert our engineering resources to redesign circuit boards to use alternate chips. But as a result, we've maintained the ability to build and deliver products And the downside is now that we carry a large cost of inventory of electronic components.
Another pretty well-known issue of this era is skills availability. Pretty much anyone you speak to, they have issues with energy, they have issues with supply chains, they have issues with skills. Has that been the case for you guys?
We certainly do. Finding staff is one of our biggest challenges. We've trouble in finding staff across all levels and areas of activity, from our technical roles, such as an R&D engineer for algorithm development, to a stores person. The number of responses we get to the roles that we advertise has dropped markedly compared with the pre-COVID times. And there seem to be several reasons for this. One issue looks to be that the local ecosystem of manufacturing is just too shallow. There are very few applicants for roles in production and planning, supply chain or logistics that have previous manufacturing experience. And in technical areas, people are drawn to other industries like fintech. Another dynamic we encounter is that some candidates now have the expectation to work from home, which doesn't always suit manufacturing roles.
Your current workforce, people you can get to work here and presumably do a very good job. Tell me about those men and women.
Yeah, so we've currently got about 250 employees at our Rosebery site, and about 100 of these are involved in the production team, directly building products to ship or working alongside our technical staff to develop or build new prototypes. The production team has a high level of skill. Many have got degree-level qualifications in technical fields, and they all receive training in their specific operations. A key feature of the production team is its long-term stability. 30% of the staff members have worked here for 10 years or more, and the culture is quite unusual. It's one where the operators, R&D and engineering staff all work side by side with daily interaction, which allows for a lot of explanation and discussion between them, and we've seen this has a very positive effect on the knowledge level within the whole team. But because of the technical complexity and wide range of products and frequency of new development, the activities of production staff are constantly evolving, which gives an ongoing interest and training. And many people who started in our production team have actually grown and gone on to new roles across the company, from R&D and engineering to supply chain. It's also notable how people from Finisar have grown their careers and now hold significant roles in high-tech companies across Sydney in the biomedical and other new startup companies. Having said that, though, the workforce is very stable. The average tenure of our staff is over 7 years, with 40% having been with us for more than 10 years.
And what's your R&D team look like?
The company's highly committed to innovation. We've got over 100 people engaged in technology, product development or engineering roles. And 50% of these people have completed some form of postgraduate education, with 25% having completed PhD degrees. We've got 4 groups, each consisting of multiple teams working on different aspects that we require to deliver a new product. And the complexity of those products demands expertise from a variety of scientific and engineering disciplines. So the first group is led by Dr. Glenn Baxter, and they focus on the essential technology within our products. He has got 3 smaller teams consisting in areas of optical design, mechanical design, and algorithm development. These teams include expertise in mechanical, optoelectronics, chemistry, physics, and lots in between. I'd expect that if added up, these teams would have well over 300 years of experience in the field of photonic product development. The second group is led by Dr. David Pasela, is engaged in product realization. He has 5 teams covering areas of electronic design, embedded firmware, semiconductor processing, process engineering, and reliability engineering. The third group, led by Dr. Ian Clark, builds on our extensive photonics design and measurements skills to develop a range of advanced optical instruments. And we manufacture and sell instruments to universities, research organizations, and the photonics industry. And then the fourth group, which I lead, develops automated machines and digital systems for manufacturing. And these teams cover areas of mechatronic and mechanical design, the automation software, cloud data systems, and the manufacturing execution system.
Partnerships with universities and other outside entities important to what you do?
Yes. We work closely with outside partners, including universities, research institutes, to help develop and test our products. The scope and engagement with these partners ranges from the use of specialised services, such as material analysis, through to development programs in waveguide design and waveguide processing. The instrument and R&D group has a particularly strong relationship with universities. Their interactions include taking students from UNSW and Macquarie every year for internships or special projects, and giving guest lectures to the University of Queensland and attending career nights at the University of Sydney. Ian is a co-supervisor of a PhD student at the University of Sydney who worked here on our staff. We currently have another person finishing their industrial experience as part of their degree. And through these activities, we witness the importance of knowledge sharing between organisations. And often through people's career progression from one company to another, we see that as crucial to the development of a critical mass in the high-tech industry.
Right. And you mentioned earlier that this company has exported over $2 billion of equipment over the years. So I'm curious about who these exports were to. Tell us about your customers, please.
Yeah, that figure of 2 billion is about right. We export to companies that build systems, and they sell the systems around the globe for expansion of telecommunications infrastructure to support the growing demand for smart devices, big data, and the implementation of 5G networks. So we deliver our products directly to these equipment builders or their contract manufacturers, which they engage to build their systems. And our main customers include Ciena and Infinera in the US, Nokia and Alcatel-Lucent in Europe, Huawei, ZTE, and Fiberhome in China. So basically, it's all the big telecom equipment producers.
Last group of companies you mentioned were in China. Obviously, with China, there's all sorts of tensions over the years. Have they been an issue for you guys for, either importing what you need or exporting what you make?
Yeah, as you noted, a large portion of our exports have been to Chinese customers. So we're very sensitive to ensuring that we don't use components that fall within restrictions that are based on technology content. And as technology restrictions between US and China first came into place, we faced significant upheaval that stopped our production lines. But to ensure the compliance, we actually changed components and found alternate suppliers. And so now, and since then, we carefully monitor all the regulations, and we've managed to avoid any further disruptions.
And so this is a question I like to ask all guests, and I'd really like to know your thoughts. Why is it important that this country have a strong manufacturing ecosystem?
I mean, basically, no country can be an innovation leader without manufacturing. The manufacturing sector is the strongest driver of innovation within the economy, and Australia cannot expect to rely on traditional resource extraction to support the economy into the future. We need to innovate. Manufactured goods account for over 2/3 of the world's merchandise trade. And a country that cannot successfully manufacture for export will not be able to participate in this trade. Where we adopt manufacturing technologies such as robotics, Industry 4, and some of the things that I've shown you downstairs on our tour, production costs in Australia can actually be competitive relative to other industrial countries. And then we see even small remote countries like Korea, Ireland and New Zealand and Israel, they are all increasing their manufacturing output and creating manufacturing jobs. And I think we should be able to do the same. Manufacturing supports many thousands of jobs throughout the economy in suppliers and services. So a strong manufacturing sector benefits the whole economy. And if Australia does not add value through the expansion of our manufacturing sectors, we can expect that our relative standard of living will decline and our vulnerability to future supply disruptions and health crises will only increase. So I think that we can and we must build a manufacturing sector that is economically and ecologically sustainable and that adds resilience to Australia's economy.
My neck is sore from nodding in agreement. And so lastly, is there anything you want to plug? It's the end of the interview, you've got the floor.
Okay, it's not really a plug, but what's on my mind is that I've seen recently a kind of resurgence in new high-tech manufacturing in Australia, particularly in Sydney. But I'm really concerned now that the current economic environment and uncertainties on the global outlook is going to have a negative impact and reverse those recent gains. So I'm hoping that these negative effects will be countered by even greater efforts to boost the manufacturing ecosystem through our clear strategy and investment environment and through a mix of education and collaboration to help build that skills base to enable the momentum to continue.
Well, I believe that's all we have time for. So, Jon, thank you very much for joining us here on AU Manufacturing Conversations.
Well, thank you very much, Brent. It's been a pleasure to have you here.